Hello everybody, I am back earlier than expected. All thanks to my mom, who I want to give a personal shout out to, since she came over and helped me move this board because I can't move it by myself right now due to restrictions from surgery, which hopefully those will lift come Wednesday. But I just want to thank my mom for helping me out so I can continue to teach, because I've missed teaching you guys, I've missed being here. So I thank everyone for bearing with my absence, and I look forward to continuing on. So today we're going to talk about how to prove lines parallel. Well, if we recall from the last lesson, we had a postulate that stated if two lines are parallel and they're cut by a transversal, then the corresponding angles are congruent. Today we have the converse of that postulate. This one states that if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So here you have lines L and M. They're both cut by transversal line N. And they give us that angle 1 is congruent to angle 5, which are corresponding angles. Angle 2 is congruent to angle 6. Those are corresponding angles. Angle 4 is congruent to angle 8. Those are corresponding angles. And then angle 3 is congruent to angle 7. Those are corresponding angles. So by this theorem, since the corresponding angles are congruent, we can go ahead and state that line L is parallel to line M. So pretty simple. It's just the converse of the original theorem we learned. Now, of the original postulate. Now, There are a few more converses today, then 2 more theorems to learn. So there's going to be a lot thrown at you today, but it's really not that bad. Over half of them are converses. Just got to change the wording a little bit here to make this next one. Now let me set up, let's see. Okay. So, we also talked about a theorem last lesson that stated if two lines are parallel and a transversal cuts those two lines, then alternate interior angles are congruent. Well, today we have the converse of that theorem. It states that if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So here again, we have lines L and M with transversal line N cutting both of those lines. They give us that angle 4 is congruent to angle 6, which are alternate interior angles. And that angle 3 is congruent to angle 5, which are also alternate interior angles. Therefore, by this theorem, we can say that line L is parallel to line M. So, that's how that one works. Really not much to it. And then I have one more converse, well actually 2 more converses, but okay, so we also talked about a theorem last lesson that stated if two lines are parallel and a transversal cuts those two lines, then same side interior angles are supplementary. Well, we have the converse of that theorem today. It states if two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So here again, we have lines L and M cut by transversal N. They give us that angles 4 and 5 are supplementary, being same side interior angles, They also give us that 3 and 6 are supplementary angles, being same side interior angles. By this theorem, we can therefore deduce that line L is parallel to line M. So yeah, it's pretty straightforward. It's just the converse of what we've done so far. Isn't much to this. It's just the converse reasoning of what we've done. Alright, I have one more converse theorem, then I have 3 new theorems to roll out, which are very small actually. So let's go ahead here with our last converse. First, let's draw a pretty little diagram. Here's line L, here's line M. Here's going to be line N. Let me put up perpendicular markers because this one pertains to perpendicular lines. Okay. Now this theorem states in a plane, 2 lines perpendicular to the same line are parallel to each other. So in the last lesson, we had a theorem that stated if 2 parallel lines are cut by a transversal, and the transversal is perpendicular to one of those lines, then it's perpendicular to the other one also. Well, we have the converse today that states in a plane, 2 lines perpendicular to the same line are parallel to each other. So we have lines L and M. They are cut by transversal N. Transversal N is perpendicular to L and it's perpendicular to M. Therefore, we can deduce that L is parallel to M. So let's go with what we know. We know that L is perpendicular to N. We know M is perpendicular to N, which would have to mean that L is parallel to M based on this theorem. So, also not very hard to understand, honestly. It's really not that hard to understand here. So, that's that theorem. Let's move on to the next 3, which are very small theorems. Alright, let's draw our diagram here. This will be line L. Here I will have point R. Okay. This theorem states here that through any point outside of a line, there is exactly one line parallel to the line. Okay. So this theorem states that through any point outside of a line, there is exactly one line parallel to the line. So here we have line L, then outside of line L we have point R. Well, this theorem states that through this point R, there is exactly one line parallel to line L. So let me illustrate. Let's draw that line. We'll call this line M. So by that theorem, we can say that line L is parallel to line M. Pretty simple, right? Really not a bad theorem to understand. Alright, let me move this R. You're all going to see why in just a second. I'm about to do that. And then there's a similar theorem, only it doesn't pertain to parallel, it pertains to perpendicular. So this theorem states that through any point outside of a line, there is exactly one line perpendicular to the given line. So again, we have line L, and outside of line L, we have point R. This theorem states that through this point R, there is exactly one line perpendicular to L. We'll call this line T. This theorem would state then that line L is perpendicular to line T by that theorem. So, also really a piece of cake. It's really not that bad to understand. And I just got one more theorem. That'll be all the theorems and postulates for today. I'm just going to draw 3 parallel lines. There's a reason for that. Line L, line M, and then we have line N. Okay. This theorem states that if 2 lines are parallel to a third line, then they are parallel to each other. Okay, so this theorem states that if 2 lines are parallel to a third line, then they are parallel to each other. So we're going to be given here that line L is parallel to line N. Oops. Not where I wanted to go yet. Line M is also parallel to line N. So we have L parallel to N, we have M parallel to N. Well, that's going to mean then simply that line L would be parallel to line M. So if these 2 lines are both parallel to N, then these 2 have to be parallel to each other. That kind of makes sense, because if even one of these wasn't parallel to one of the lines, they would intersect both the lines at some point. It would screw the whole thing up. So that one seems almost like a duh moment, but it's a theorem. I gotta teach it. But that's it for the new theorems today. Now we're going to do a couple proofs. Let's do a nice couple proofs. Alright. Let me draw my diagram here. L, N, this is T. Okay. So here, what we have in this diagram, we have lines L and N. They're both intersected by transversal line T. These arc marks mean that angles 1 and 2 are congruent to each other. Then we have an angle 3. Well, This is a proof here. So what we've been given, what they give us in this particular one is that transversal T cuts L and N. They also give us that angle 1 is congruent to angle 2. What we are tasked with proving is that L is parallel to N. So we're given that transversal T cuts lines L and N, as we can see from the diagram. They even tell us that angle 1 is congruent to angle 2. They give all that to us. Based on all this, we have to prove that line L is parallel to line N, because right now we can't prove it just yet. So let's go ahead and set up our two-column proofs. Alright, so let's start with our given information for our first statement. That's going to be that transversal T cuts lines L and N, as well as the fact that angle 1 is congruent to angle 2. That's all given. So that would be your first reason. We've used the given information. So where do we go from there? Well, let's take a look here. Angles 1 and 3 are vertical angles, are they not? We can therefore say that angle 1 is congruent to angle 3 by that theorem that vertical angles are congruent. That would be the reason for that statement, that vertical angles are congruent. Okay, next. So we know angle 1 is congruent to angle 2. Angle 1 is also congruent to angle 3. Therefore, by the transitive property, we can say that angle 2 is congruent to angle 3. We can use the transitive property to say that angle 2 is congruent to angle 3 by the transitive property. Now it's apparent that angle 2 and angle 3 are corresponding angles. So we can, for step 4, go right to our proof and say that lines L and N are parallel. Line L is parallel to line N. The reason for that is, if I'm going to abbreviate this, if corresponding angles are congruent, then lines are parallel. Okay. So line L is parallel to line N by the fact that if corresponding angles are congruent, then the lines are parallel. So let's go over this proof again here. Statement 1, we use the given information to state that transversal T cuts lines L and N, and angle 1 is congruent to angle 2. That was given. The second thing we can do, we observe that angles 1 and 3 are vertical angles, so angle 1 is congruent to angle 3 by vertical angles are congruent. Which means the third step is we can say angle 2 is congruent to angle 3 by the transitive property. And then we know that angles 2 and 3 are corresponding angles, which means that we can deduce that lines L and N are parallel to each other, that if corresponding angles are congruent, then the lines are parallel. So that's how we're going to prove that L is parallel to N. Pretty basic proof, right? I have one more proof and I have a few algebra problems for today. Which they'll be geometry algebra problems, not just standalone algebra problems. Alright, what do we got here? Draw me a nice triangle here. C, D, and that should be A. Alright, that goes to DB. This goes to E. Alright. Here's angle 1. There's angle 2. Here's angle 3. So we got a nice triangle split into 3 sub-triangles with 3 angles. What's this proof about? Well, this proof is about what they've given to us to start with. The given is that line segment BE is perpendicular to line segment DA. And then we have that line segment CD is also perpendicular to line segment DA. They've given us that. We have to prove that angle 1 is congruent to angle 2. So this will be another fun proof. So let's go ahead, let's start out with the proof here. So let's start with our first statement. We'll start with our given statements that line segment BE is perpendicular to line segment DA, and that line segment CD is perpendicular to line segment DA. That's our given information. That was given to us. So here BE is perpendicular to DA, and then CD is perpendicular to DA. That was given to us. Where do we go from here? Well, so BE is perpendicular to DA, CD is perpendicular to DA. Both these lines are perpendicular to DA. We actually would next say that line segment BE is parallel to line segment CD. How would we conclude that? By that theorem states that two lines perpendicular to the same line are parallel to each other. So by the theorem that states two lines perpendicular to the same line are parallel to each other, we can therefore conclude that BE is parallel to CD. Okay? And then, looking at the diagram, the third statement we want to make is that line segment BD is transversal to line segments BE and CD. So line segment BD is transversal to CD and BE. Well, how will we conclude that? If it's in the diagram, you can count that as given. So if you see it in the diagram, you can also count that as given information. That BD is transversal to BE and CD. Which would then leave us to angles 1 and 2 are congruent since they're alternate interior angles. Angle 1 is therefore congruent to angle 2 by that theorem that states that alternate interior angles are congruent. So let's go over this proof again. We start with the statements that line segment BE is perpendicular to line segment DA, and then line segment CD is perpendicular to line segment DA. That's the given information. And then we can conclude that line segment BE is parallel to line segment DE by the fact that two lines perpendicular to the same line are parallel to each other. And then based on the diagram, which would count as given information, line segment BD is transversal to line segments BE and CD. Which then, we know that angles 1 and 2 are alternate interior angles, meaning that angle 1 is congruent to angle 2 by alternate interior angles are congruent. So, again, that wasn't that bad of a proof. I mean, proofs can seem overwhelming at first, but once you figure out the approach and really understand all the theorems and postulates that we've learned and apply them on a regular basis, it's really not that bad. Now I have a few algebra problems here. So let's go over those here. First, let's state the objective. Find the values of x and y that would make the red and blue lines parallel. Okay. You're about to see what I mean by that here. So let me draw a nice diagram. Alright, so let's set this up here. So, we have here, we need to find the values of x and y that would make the blue line parallel to the blue line and the red line parallel to the red line. For the sake of this problem here, we're going to assume, let's start with finding our x first. We can start by operating under the assumption that the red line is parallel to the red line, right? Which would mean this blue line is a transversal to those two red lines. Which would therefore mean that these two angles here would be same side interior angles. So x minus 40 and x plus 40 are same side interior angles, which means they're going to be supplementary to each other and add up to 180. So let's take x minus 40 plus x plus 40. We'll set those equal to 180 since they're supplementary, which would just mean you get 2x is equal to 180, which would just mean x equals 90. So the value of x that we're looking for would be 90. Now we need to figure out y. Well, now to figure out y, we want to operate under the assumption that these two blue lines are parallel to each other and the red line's the transversal, which would have to mean that x minus 40 and y are same side interior angles and supplementary, which means they're going to add to 180. So you're going to take that x minus 40, which would really, we'll put in that 90 for x. That would be 90 minus 40 plus your y. You're going to set all that equal to 180, which would mean you'd have y plus 50 equal to 180, which would therefore give you that y equals 130. So the value of x we're looking for to make these lines parallel to each other, x would have to be 90, y would have to be 130. So these type of problems, you operate under the assumption that the lines are parallel, and then you just solve for your x and y. So not as bad as it looks. These aren't quite like doing proofs where you don't know if they're parallel. You have to operate under the assumption they are parallel. Alright, what's the next one here? I don't think I want to quite go that low because I need room to work. Better extend this out a little more. I think I'm going to need to. Okay. Here's a fun one. Alright. Let's do the next one here. What do we got? This one would be 3x. This particular angle is. This one they give here is 105 degrees. This one they give here is 2y. This one they give here is x. Okay. Well, looking at that, how in the heck are we going to solve this for x and y? Well, let's start here. We're going to operate under the assumption that these red lines are parallel to each other, right? This blue line would be the transversal between them, which would have to mean that 3x and 105 are alternating interior angles. They're alternate interior angles, so in other words, they're congruent. So that means you're going to set 3x equal to 105, which would just mean that x equals 35. And just like that, we got x. X is equal to 35. Pretty basic. Okay, so x is 35, right? Well, now we can't go directly for y, not just yet. Again, let's operate under the assumption here that these two blue lines are parallel to each other, right? So that means this big long black line would have to be the transversal between them. This angle would correspond to this one, so that means this is also x right here, since they would be corresponding angles. Well, we know the value of x now, it's 35. If we take the value of x plus 105 plus 2y, wouldn't we get 180? So let's go ahead and do just that. We'll take 35 plus 105 plus 2y, we will set that all equal to 180, which would then mean you would get 2y plus 140 equal to 180, which would just mean that 2y equals 40, which would then give you y equals 20. So the values of x and y that would make these lines parallel to each other are x equals 35 and then y equals 20. So, also not terrible. Alright. Let's do here a couple more. Let's do a few more problems. It's going to be a little bit different with these ones, but they're still algebra nonetheless. All right. Find the measure of angle RST. So this is a little bit different here. We're about to find an angle measure, but not quite as simple as it sounds. All right. That's X, that's R. This is S. Here's T. Here's Y. As a matter of fact, we even are given that line segment line RX is parallel to line TY. Furthermore, we're given that this angle here is equal to 40 degrees. We're given that this angle here is equal to 70 degrees. What we need to find now is the measure of this angle RST. Well, how in the heck are we going to do that, you're probably wondering. So there is a way to approach this. Remember that theorem we just learned that through any point outside of a line, there is exactly one line parallel to the given line? So you could pick line RX or line TY, it doesn't matter. You can actually draw a line through point S here that is also parallel to these two lines, okay? And then it would also state that two lines, you have a theorem we learned today, that two lines parallel to a third line are parallel to each other. So that's how we're able to draw a fake parallel line, by those two theorems, and solve this. Okay, now we have a couple things here. We know this blue line is parallel to line RX, right? If that's going to be the case, if that's the case, then that would mean RS here, line segment RS, would be the transversal between lines RX and the line going through S. So you have 40 degrees here, and then over here you would have 40, because these would be alternating interior angles. So you'd have 40 degrees here. And then we also know this line going through S is parallel through line TY, which would have to mean that ST is a transversal between those, which would mean this angle here would have to be 70 since they're alternating interior angles. So we got these two angles here now together make up angle RST, do they not? So all you're going to do now is take 40 degrees plus 70 degrees. That's going to equal the measure of angle RST, which would have to mean that the measure of angle RST is equal to 110 degrees. So And we're going to have one more problem like it, okay? You have two lines here. They tell you you're parallel. Forget about that blue line for a second. They want you to find the measure of angle RST. Well, remember that theorem that states through any point outside of a line, there is exactly one line parallel to the given line. That's how we're able to draw this third parallel line in that wasn't there before. And then two lines parallel to the same line are parallel to each other, so that's how we know all three of these are parallel, okay? So if this line's parallel to this one, that means the angle in here formed by the blue line and RS, this would have to be 40 because these would be alternating interior angles. Same here, you'd end up getting 70 for this angle, so you add 40 and 70 together, you'll get the entire measure of angle RST by the angle addition postulate, if you will. You get it as 110. So it's important to also know the theorems. Alright, we have another problem like this, but a little bit different. So let's see. XR S T and then Y. They give us that lines XR and YT are parallel to each other. So we are given that. They give us that angle XRS is 110 degrees. They give us the angle YTS is equal to 120 degrees. We got to find the measure of angle RST. So, how are we going to do that? Well, like the same reasoning as before, just as I should say the same reasoning as before, we can draw a line through point S that is parallel to both of these lines here. So we're going to do just that now. I know it's probably not the straightest, but you'll get the point. So we can draw a line that is through line S that is parallel to XR and YT. Now, this one actually, to me, is a little simpler than the last one, because this angle is 120. You have this line from S parallel to YT, do you not? That'd have to mean the angle down here would be it would have to be a same side interior angle to the 120, which would mean you'd have 120 plus this angle being 180, so this angle would have to be 60 degrees, would it not? You'd have 60 degrees here. Okay. Next thing, we know XR is parallel to this line from S, which would mean this angle right here would be parallel, it would be same side interior to 110, meaning that's also supplementary. So subtract 110 from 180, you get this angle being 70 degrees. So 60 plus 70, the measure of angle RST is going to equal 60 degrees plus 70 degrees, which could only mean that this angle is equal to 130 degrees. So the measure of angle RST in this case is equal to 130 degrees. So in these type of problems, yes, you may draw additional parallel lines by the theorems that we've learned today. So that's why these theorems we're doing are so important. I got two more problems, then we're done for the day. All right. Last two problems. Find the values of x and y that make the red lines parallel. So we're going to find some values of x and y that make lines in red parallel to each other. So let's see here. Do. Extend this a little bit. Okay. Let's see here. This would be red. Through here would also be red. So here's the red lines that were being referred to. Now let's throw in some angle measures. This angle's 30 degrees. This angle's 5y degrees. This angle is 2x degrees. This one here is x minus y degrees. Okay. So we have a fun one here. So we're going to operate under the assumption that these two red lines are parallel to each other, are we not? So if these two red lines are parallel to each other, that would have to mean that the x minus y would equal 30 because those are corresponding angles. So what you'll have is that x minus y equals 30. And then again, if these red lines are parallel, that would mean this line here is a transversal between them, so that would have to mean that 5y equals 2x, because they'd be alternate interior angles. So we could put here that 5y equals 2x. Well, what do you know? We have another system of equations to solve. So it's a good thing we're doing these problems here. We can get some good systems of equations review. Well, I think it's obvious we want to pick substitution. That would have to mean that y equals 2/5 x. That's all that can mean, is that y equals 2/5 x. So let's go ahead here. Let's put in the 2/5 x here. So x minus 2/5 x equals 30, which would have to mean that 3/5 x equals 30, which would then have to mean that x equals 50. So the value of x that you're going to get is that x equals 50. Now we know that y is equal to 2/5 x. We'll just substitute that value of x in here. So y equals 2/5 times 50, which would just simply have to mean that y equals 20. So the values of x and y that would make the red lines parallel in this case are x equals 50, y equals 20, by a wonderful system of equations. And I got one more. This one may be the most important. I'll explain why in a minute. Actually, they want to start with red today. Okay. So there's our two lines that are red. Here's our transversal. So this angle is equal to x squared. This one is just equal to 3x. No y's in this, but I'm going to leave this statement in there anyway. We only got to solve for x. We got to figure out the value for x that would make both of these red lines parallel. Well, we know that if these are parallel, that x squared and 3x are same side interior angles, which would have to mean that they're supplementary. So what you're about to get now is that x squared plus 3x equals 180, right? Well, we have a quadratic equation. To solve this, we want to make the right side equal to 0. So that would turn into x squared plus 3x minus 180 equals 0. Well, I can tell you right now this isn't going to factor. We know it's not going to factor, is it? And completing the square is not going to be a pleasant experience because you're going to get fractions. That leaves us with no real other option but to use the quadratic formula. Anyone forgets the quadratic formula is x equals the negative of b plus or minus the square root of b squared minus 4ac all over 2a. There's a bit of algebra review. So x equals the negative of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so let's go ahead and plug in for the quadratic formula. That means x would equal the negative of b, so that'd be negative 3 plus or minus, see, the square root of b squared is 3 squared, that'd be 9, minus 4 times your a, which is 1, times your c, which is negative 180, all over 2 times a, which would be 2 times 1, just simply 2. Okay. Let's move this up here, which means x would equal negative 3 plus or minus the square root of 9. Now, negative 4 times negative 180, that's going to give you positive 720 all over 2, which therefore means that you're going to get negative 3 plus or minus the square root of 729 all over 2, which means that you'll get negative 3 plus or minus 27 over 2. Square root of 729 would be 27. Okay. Well, here's the thing. In a normal quadratic situation, you're going to have two solutions, right? Negative 3 minus 27 would give you negative 30, then divided by 2 is negative 15. If I put negative 15 in here, I'll get a positive angle of 225, which already blows the 180. And if I put the negative 15 in here, I'll get a negative 45 degree angle, which in this course, there's no such thing as negative angles. When we get into trigonometry and Algebra 2 trig, that's a different story. There is a time and a place for negative angles, but in this entire course, negative angles don't exist, okay? So we throw out the solution that would make it negative. we only are worried about a positive angle. So if we take negative 3 plus 27, you'll get 24 over 2 would be 12. So therefore, x could only equal 12. That would be your solution in the end, is that x would equal 12. So that's it for this lesson. Next lesson, we're going to start talking about angles of triangles. We'll talk about the types of triangles, and then there'll be some theorems, and even what's called a corollary, which are like sub-theorems of those theorems. All about triangles next lesson. So I hope everybody has a good night. Take care.